Hello. In this video, we're going to talk about proportionality and fairness. So we're in the section of gerrymandering, and we're going to be talking about how do we know if a map is fair or not. So one thing that's really useful to talk about is proportionality. So what proportionality means is think about equal fractions. For example, if one party has 1/4 of the population, you would expect that they would have about 1/4 of the seats in that state. So that would be a basic measure of fairness. If one political party had only, say, 1/4 of the population, but they had 3/4 of the seats, that doesn't seem very fair. Okay, now there's nothing in our Constitution or law that says representation must be proportional. And people can vote for a different party than they belong to. It's just that that has become less and less common over time. People have been more split over party lines lately. So there's nothing that guarantees this, but it does seem like a basic measure of fairness. So we could use this to decide if a particular map is fair or not. Okay, so let's look at a couple of examples, one with fractions and one with decimals. The first one is, if a state with 10 districts is 3/5 Democrats and 2/5 Republicans, how many seats would each party get if the representation was proportional? Okay, so you might know that to take a fraction of a whole number, you multiply. So we have 10 districts. So let's write for D for Democrats. 10 districts times 3/5 equals, and we can make this 10 over 1. Let's just refresh our memory on fractions. So if it's a whole number, we put it over 1, and then we multiply straight across. So this is going to be 30 over 5, and then we can reduce or divide. 30 divided by 5 is 6. Let's check it on the calculator. We could do 10 times 3 divided by 5, 10 times 3/5, or you could use your fraction key, and it comes out to 6. Okay, so the Democrats would have 6 representatives or seats. And then let's do the same for Republicans. You can probably guess what it's going to be since they have to add up to 10. 10 times 2/5, but it's good practice. 10 over 1, so that is 20 divided by 5, or 20/5, which is going to be 4. Okay, so as you can imagine, not every example is going to come out very nice like this. I wanted to start with one that came out even, so you could see this representation is exactly proportional, so it seems exactly fair. But in real life, we have an odd number of seats, or we have different decimals or percentages of political parties, and so it's not always going to come out so nicely. So let's look at an example like that, and this one also uses decimals instead of fractions. So let's start with Democrats here since they're listed first. So now we have 9 times, instead of a fraction, we have a decimal. So we're going to multiply. We're going to change this, we have a percentage. We're going to change that into a decimal by moving it to the left 2 times, 0.423, and see what that equals. And for the Republicans, we're going to take 9 times 0.577. Let's see how this turns out. So 9 times 0.423 is 3.807. 3.81, I could have rounded it. And for the Republicans, we have 9 times 577. That's 5.193. Okay, now they did not come out to whole numbers, so one thing we might say is, well, let's go ahead and round them and see. So 3.8 is closer to 4 than it is to 3, so we're going to round to 4, and 5.193 rounds down to 5, and that does add up to 9. So while this isn't entirely fair, because Democrats actually should have just under 4, so they're getting a little bit of an advantage here, and the Republicans are losing a little bit of advantage here. This is fairly fair, or pretty fair. Sometimes if it's close, you know, you might say, well, either 4 to 5 is fair, or 5 to 4 would also be pretty fair. Sometimes there's two that are pretty close together. So we just want to say which combination is closest to fair, as close to fair as we can get with the given numbers. Okay, I hope you found that interesting, and we'll talk about how to measure gerrymandering with the efficiency gap in the next video. So I'll see you there.